So hey everyone, thanks for joining. My name is Kevin Ko, and today I'll be talking about machine learning workflow orchestration with Prefect. So a bit about me. I currently work as an open source community engineer at Prefect. So I am primarily responsible for supporting our users in the Slack community and also giving like talks like these in meetups or conferences. So when I hear Prefect users like present at other venues, they always mention that uh, being part of the Slack community is something that they learn a lot from. They find it very engaging. There's a very active community. So if you're just interested in talking about workflow orchestration, you're not planning on using Prefect, you're still very welcome to join our Slack community. Uh, I'll have the links at the last slides, but it's going to be like prefect.io/Slack. Prior to joining Prefect, I was a data scientist for 4 years uh, at Paylocity, which is a payroll company. I was doing some like HR, machine learning stuff. And then at Itron, which is a electric metering company, I was doing some machine learning like with like smart grid and like utility infrastructure and that kind and smart applications on top of that. Outside the work, I contribute to Fugue, which is a abstraction layer for distributed computing. So it lets you use Python, Pandas, and SQL code on top of Spark and Dask. And I am from Orlando, Florida, and I am actually a meetup organizer. I organized the Orlando Machine Learning and Data Science meetup. But Prefect is very much a DC-based company, so it's very excited to present at this meetup, and we look forward to being more involved in the DC data community. We are planning to be involved in Data Week DC, still shaping how, still working, seeing how that will take shape. And then I took this screenshot today of our UI, and if you look at the bottom, it'll say made in love with in DC. So I would say more than half of our employees are DC based. We had an office in DC before the pandemic, and then after during COVID, everything went remote, and that's when Prefect started hiring remote employees. So for today's talk, first we'll talk about workflow orchestration, the use cases, and like a brief history of Prefect, and then we'll go over a simple like Python like use case, a simple problem together. And through that, we'll go over the Prefect basics and see how you would take like a Python script and turn it into a Prefect workflow. And then third, we'll look at how Prefect and Dask work together to use the power of the distributed computing engine in order to parallelize workflows. And then four, because this is a data science meetup, I am going to do a parallel grid search on top of Dask using Prefect. And with that, let's get started with workflow orchestration. So if you're not familiar with workflow orchestration, just a brief introduction. Here we have a machine learning pipeline, and what we're doing is we're ingesting data from multiple sources. So here we have a database query that saves stuff into maybe a Parquet file, and then the start of our Python workflow, where pandas will load these different file sources, these different data sources, maybe train a machine learning model out of it, persist some artifacts from that machine learning model, like maybe your model metrics, maybe some plots to look at later. And then maybe you want to deploy that machine learning model into a Flask server and make an API out of it. And this is like a pretty standard one-dimensional data science pipeline. It's pretty straightforward. But even in this case, we still have a lot of points for failures. But before we go into that, let's group, like, if we were to like actually look at the dependencies here, right? We have this database query feeds into this Parquet file, right? This REST API is needed for the data munging to happen. And then after this all completes, maybe these two would be together in one step, and this would be in a step. So when we talk about workflow orchestration, we're talking about orchestrating these like dependencies and these pipelines. So in a real like data science use case, you, especially if these like transformation steps and these modeling steps become very involved, you tend to split them out into separate scripts or jobs. So here in this case, the pipeline would trigger these steps one at a time in sequential order. And a workflow orchestrator is responsible for managing the dependencies, making sure that something finishes before triggering the execution of the downstream tasks. So in this case, we would make sure that all the upstream dependencies succeeded correctly, succeeded before we would start the model training, right? So in some cases also, you want your workflow orchestrator to prescribe logic in the case of failure. So for example, this API, right? At my last job, we used an API that scraped LinkedIn profiles, for example, but it wasn't a significant part of the machine learning model. So even if the REST API call failed, we would still train our model, right? And we would still schedule this training, even if this failed or not. So you, if you have logic like that, you want to prescribe that, you can say like, oh, this task is critical or this is not critical, and I still want things to proceed. That is the purpose of a workflow orchestrator tool. So we look at the points of failure, like where this pipeline can fail. It can fail in so many different ways, right? Like for example, the REST API just was down for a second and our request failed. Or what if the database and the underlying server or this database failed entirely, right? What will happen to our whole pipeline? What happens if data comes in malformed and it breaks our pandas transformations? What happens if let's say even modeling can fail? Like if you have, for example, models that um, kind of cannot converge, or if they cannot like if they, for example, if the statistics don't work out and your models fail, it can also fail in that way. Persisting records to MLflow can also fail, right? Like what happens if you're using their API and stuff just doesn't upload right? And then also deploying can fail. So the point is that when you have a pipeline or when you have any Python flow or process, there are many ways that stuff can fail. And failure is just really a part of the job. And so with Prefect, we want to abstract this work away from you, and we want to make sure that you focus on building out the actual pipeline rather than safeguarding against failure. So if you think of like all the ways that this can fail, and each of them is solvable in a sense that, hey, the API didn't work out, I can code and add retries to it. Hey, the pandas transform didn't work out, I can do some try catch and add some extra logic. Or even the machine learning model, maybe this one you can't really help, but a lot of times you can code against failure. You can code against you can expect what's going to happen and have some safeguard against that. And then Prefect, we call that negative engineering, right? So we talk about positive engineering as the things that you want to do and what you set out to begin with, the modeling, the data analysis and stuff. The negative engineering would be the things that are added work just to get your positive engineering working, right? So here we have an example of a more interconnected pipeline. And this bottom pipeline is the pipeline I showed you earlier. But what if those files are also being used by other pipelines? And now that we have this like interconnected network, like these interconnected steps, how do we manage the dependencies such that so, like how do we code in that certain tasks still need to continue or still need to run even if upstream tasks fail? Or how do we make sure that to stop downstream tasks if the upstream tasks fail, right? So that's what workflow orchestration is for. It can even, a lot of times you have these interconnected pipelines in data organizations, where here we have a data science pipeline and here we have a BI pipeline, but they would still use the same data sources. So we need to we need to make sure that these upstream tasks succeed. So one of the more interesting use cases I've seen of Prefect was you can kind of structure your workflows in a modular way. So I saw one of our users, what they did was they had a a main workflow comprised of these 5 subflows, and the subflow would check for new data that came in. If it came in, they would pre-process it, upload it to a registry, and then do their machine learning models, and then deploy the model. But based on certain triggers, sometimes they just wanted to run steps 4 and 5. Sometimes they, if new data didn't come in, they just wanted everything to skip. In some cases, they just want to run like 2 and 3 if they change the logic. So because of this like modular setup, again, a workflow orchestrator can also help you like determine the logic, the relationship between these subflows, and like how you're gonna, like for example, if no data comes in, what are the actions you're gonna take? If data comes in, what are the actions that you're gonna take? Let's say you train a machine learning model, but it wasn't any better. Do you still deploy that or not? So when we talk about negative engineering, and this is exactly why Prefect was founded. When Prefect was founded, our our founding team, they talked to a lot of data engineers, data scientists, and you'll commonly hear that basically 80%, 90%, or 80% or 90% of the work is negative engineering, right? And if you think of 90% of the work being negative engineering, then Prefect's goal is to bring that 90% down to 80% or 70%, and that in effect doubles or triples like positive time devoted to positive engineering, right? So Prefect's mission is to eliminate negative engineering. And when we talk about these things that can go wrong, these retries, this malformed data, you want to code your own notifications, get alerts on Slack, or you want some conditional failure logic. These are things that Prefect wants to do for you in a very, make it easy for you to do so that you can really just focus on the positive engineering tasks. And that's where Prefect was formed. So our founder was, if you guys are familiar with Airflow, Airflow was kind of the first widely adopted workflow orchestration system. And our founder at one point was the had the second or third highest number of commits into Airflow. And basically Prefect, you could say, was a list of changes that he proposed in order to make an Airflow 2.0 that were not adopted. And so he decided to make Prefect. So Prefect is an open source workflow orchestration system. We currently have around 6,700 stars on GitHub. On Slack, we have around 7,500 users, and it's growing rapidly. I'm always on Slack, like I mentioned. I answer support questions, so feel free to join our Slack. Prefect is primarily Python-based and designed for the modern data stack. So when we talk about being Python-based and designed for the modern data stack, like a lot of our users, yes, we have data engineers that are users, of course, but we also have a lot of data scientists and data analysts being responsible for their own workflow orchestration, right? Because having it being Python-based makes it live alongside your like data application logic also. And then we also, when we say design for the modern data stack, it's really this Prefect is really designed to handle the volume of data that we're seeing today. So when we talk about like Airflow, for example, and it was made in 2014, like data wasn't as big as what we're seeing today, more ubiquitously. So Prefect is really designed to handle that scale. And I'll show a bit more how later. And one of those ways is having the native Dask integration. So if you're not familiar with Dask, I'll go into it a bit more later. But Dask is a distributed computing engine, right? And Prefect can take advantage of Dask uses the Dask execution engine in order to parallelize workflows. We have a very active community, and everyone is really welcome to join. And then, so Prefect has two offerings, one in Prefect Cloud and number two in Prefect Server. So Prefect Cloud is our managed version of Prefect, and Prefect Server is an open source version that you can go and spin up on your own infrastructure entirely for free. So some of our users just stick to server, spin up server and manage it themselves, especially users from companies that have really strict like requirements that they can't have outside connections or stuff like that. And then Prefect Cloud, on the other hand, is our managed offering. Everyone who joins Prefect Cloud gets 10,000 free task runs every month, which is more than enough to get started with. So you can go in and play with Prefect for free, entirely for free, for a very long time, and it's more than enough to get started. So here's just a simple picture of the UI, but we'll dive more into it later. Green are the workflows that succeeded. Red are the workflows that failed. Gray are the canceled ones, and in the yellow we have the scheduled ones. So once you go into the dashboard, right, it shows you all the failed, like Prefect. A lot of our clients describe it as the one pane of glass that where they can see everything that happened with their workflows. So this is interactive. You can click into these bars. You can see what tasks failed, what were the error messages associated with that, where did it stop, and then you can also, even for the ones that succeeded, maybe you're interested, as I'll show later, like you can persist stuff like artifacts from that flow run so that you can go in and check them later on. And then you just see these summary statistics, how many flows succeeded, failed, etc., and the upcoming runs. So with that, we'll get started on working on a simple problem. I'll just check the chat. Thank you for posting our Slack channel. With that, I'll go over a simple problem. If you've seen me talk before, I presented this before, but do stick around because we do other stuff towards the end. So here we are going to track Dogecoin prices. And the goal is to make a script that alerts me whenever there's a dip. And I first made this talk around May, and it was crazy because, so Dogecoin has been crazy, like through the roof. Like, I mean, it was through the roof. I don't track it anymore. This is not financial advice, but I was preparing this presentation in May when there was like a big spike. And when the week I was preparing it, there was like this massive 10% just crash, right? So a lot of people are interested in tracking crypto. They want to get in during these like dips so that they can hopefully pick it up before it spikes again. So here we're going to make a Dogecoin tracker. And ignore the code for now. The important thing is, number one, we're gonna construct our URL, and then number two, we are going to get the data using that URL. Number three is just a simple, we're gonna check if there was a dip, and if there was a dip, I'm gonna send myself a Slack notification. So with that, let's get started. The first function here is just formatting the URL. You just need to note this API URL, and we are taking in a coin, and we're just formatting like this URL plus the coin plus parameters. The parameters are just start time and end time. So we're just getting like the prices for a given window. We're formatting that URL. And then here in the get data, this function returns a pandas data frame. So here we actually get that data by passing in Doge, our coin. And then we convert that request into a pandas data frame and return that. The third thing to do is, once we have our pandas data frame, we are going to set this like threshold. So here I'm calculating the peak of that window, the bottom of that window, and then I'm just like checking if there was like a big dip. So just like the bottom divided by the peak, right? And I'm just multiplying that by 100. So this is like, hey, there was a drop, kind of like, hey, there was a drop by like 10% or by 8% or 5%. That's basically it. And then if the dip is bigger than our threshold, which is 10%, then I return true, otherwise false. And the last thing is giving myself a Slack message whenever there's an actual dip. This one I won't implement with Python. I mean, I'll show how to implement it with Prefect later because it's significantly easier. So there's no point implementing this here. And like before workflow orchestration, right? Now I'm interested in running the script, and I want to run it on a loop like every 5 minutes. And then every 5 minutes, ideally, like if there's a dip, I'll get alerted on Slack, right? So I set up an infinite loop here, and at the beginning of the loop, I'll just say like sleep for like 5 minutes, and then after that, it's all the code that we showed earlier. I'm just getting my data, detecting if there's a dip, and if there's a dip, I'm gonna post to Slack, right? So what are the things that can go wrong with this, right? Like what happens if an API fails? What happens if this get data just fails just because there was a hiccup in the API, right? Then now I need to, um, now this whole script will die, and I'll have to go, if this is like running on a machine, I'll have to go back to that machine if that's an AWS EC2 instance, and then I'll have to start that process up again, right? What if I wanted to track another coin? Then I would have to, like simultaneously, I'd have to create a new process. I'd have to feed in an actual coin, and then also keep track of that other process. What if I wanted to have an off schedule run, like, oh, somebody told me there was a dip and I just want to run and check quickly, right? Then I have to, again, take out the while loop, take out the sleep, have another process, run that process, right? And then lastly, how can I get notifications if the flow entirely fails, right? Like not the Slack message, but the actual workflow failed. How do I get notifications? And I would have to code that, right? And again, each one of these are solvable. I can have retries. I can make parameters for another coin. I can have off schedule runs, but each one of them takes more effort that eventually you're going to have more code against that you're going to have more negative engineering code than positive engineering code, right? Especially when you talk about failures and retries and notifications. And that's why bringing it to Prefect will simplify this process. So here, let's get started with bringing this to Prefect. So we're going to use the same script, but turn it into a Prefect workflow. And the first thing we're going to do is the Prefect semantics are comprised of flows and tasks. So flows are more like the whole Python script, whereas tasks are more like individual functions. So so multiple tasks make a flow. And what we're going to just do is we imported tasks from Prefect, and we just applied this decorator on top of these functions. That's the only change we're making. The rest is what we had previously. And then now that we already added the task decorator to those, we can now bring it to a flow. And here we just define our flow block. So with flow as flow, and then we have our task that we defined earlier. And then once we are ready to run it and see if it works, just like running a Python script, we can just do flow.run. So there's three main things that I showed you here, right? Number one is if you look at data equals get data, and this data went into the detect dip. It's a very Pythonic API, and that's because Prefect supports a first-class passing of data, right? So other tools, they require you to persist the data somewhere, and then a downstream task has to load the data. So with Prefect, you can just directly pass that data from an upstream task to the downstream task. The second thing is, if you notice, like if you come from a world of like if you come from another orchestrator tool, you'll have to set these explicit, like set upstream, set downstream, you know, like you have to manage this computation graph, this execution graph yourself. In Prefect, because this detect dip took in data, it knows that data is an upstream task. So here we are creating the execution graph automatically. This post to Slack has no dependency, so we'll have to add that dependency later. Otherwise, there's nothing stopping it from executing at the same time as these other guys above. And then the third thing to notice is local testing, right? So again, with other workflow orchestrator tools, you have to spin up a couple of infrastructure. You might have to spin up a database or something like that, just in order to test your workflow. In Prefect, it's as simple as flow.run, and this just calls the Python under the hood with logging and like monitoring attached. But it makes it very easy for you to just test like it's normal Python. And then with our API, we said earlier that it can fail. occasionally. So we want to retry that task if it fails. So with Prefect, it's just a matter of adding the max retries and then a retry delay. So here we'll retry that every minute for 3 times, and then if it fails 3 times, then um, we won't try it anymore, and the flow will fail. The next thing I mentioned earlier is what happens if I wanted to run a flow for a different coin. Like what if I just wanted to run an ad hoc, one off schedule flow just for a different coin? So here we're gonna take in a parameter, and a parameter is just a special task that the value gets filled in at runtime. So here we have a parameter called coin, and the default is our Doge, right? So because we passed this in now we have a parameterized parameterized flow, and the next time we run it, we can specify the value of that parameter. So we can put Bitcoin or Ethereum or something else. And then when we also test, we can also do this pretty seamlessly, right? We can just do flow.run, and parameters takes in a dictionary, and the dictionary contains the parameter values. So now this would all run with Bitcoin instead of Doge. And the last thing I mentioned is that it's a lot easier to to make a Slack message and post it with Prefect than if you were to code it yourself. And that's because we have a task library with Prefect. So everything I showed you in so far is just Python code. And I said that Prefect is Python based. Because it's Python based, as long as you can do it in Python, you can bring it to a Prefect workflow. So if, for example, I know we have data scientists that use R, for example, we can wrap that in a shell task, and you can just run it as a shell task, right? A lot of these tasks are stuff that you can standardize in some way. For example, querying from a PostgreSQL database. You query from that, you upload it to S3 or to Azure. Maybe you're just moving from maybe you want to use like a Databricks job after you want to submit a Databricks job after some ETL process that was saved in AWS. Like a lot of these tasks are can be very standard, especially the database like upload and querying. So we have a community contributed task library, and around 80 to 90% of our tasks are community contributed. So here we're going to be using this Slack task specifically, and we're just going to send a message using this Slack task, and I'll show how easy that is. But in general, like we even hear some like data engineers that are not as familiar with Python, maybe they come from like a Java background, they can still get Prefect workflows together because using the task library, because it makes it really easy to do it. And with that, I'm going to show you how to use the task library. So here we're just going to import this Slack task, and I'm just going to add this line, post to Slack is Slack task, the message, there's a dip in Doge price, and then a secret, right? And then because I have this task now defined, I can just use it in my flow at the end like this. And this will post a message in Slack. The second thing about it is that if you notice, there is this secret here. So Prefect Cloud stores secrets for you. And here I have a secret that is stored that's called Slack webhook URL. So when this flow runs, it's going to pull down that secret and use it in the Slack task to send a message to that Slack channel that I'm part of. And then, so like you'd use secrets for like database connections, stuff like that. And then now that we have our Slack task up and running, the next part is to like if you remember earlier, we had this like if else type statement where like if there's a dip, we'll post to Slack. So in order to bring it to the Prefect flow, we're just going to do with case equal is dip is true, post to Slack, right? So this is like an if else statement. So now we have a coin that's coming in, we get the data for the coin, see if there's a dip, and if there's a dip, we post to Slack. So after you're done testing, like with flow.run, and you're ready to actually bring it into like to Prefect Cloud for orchestration, then you would register that project, that workflow into Prefect Cloud. So here, or server. So here we do flow.register and the name, and I'll show you that process later and how what it looks like to run it once it's on Prefect Cloud. But before that, um, we'll just discuss schedules for briefly. So normally when you have a workflow that you're building, you want to eventually deploy it with a schedule attached, right? So in Prefect, what this looks like is we have a schedule that can take in multiple clocks, and the clock can either be an interval clock or a cron clock if you prefer cron expressions. And here I'm saying that I'm gonna make an interval clock. The start date is now. Now being just datetime.datetime.utc now. And then we will run this every 5 minutes, this flow. And the default parameter coin will be Doge. So if I wanted to make another clock for another coin like Bitcoin or Ethereum, all I need to do is do it at the clock level, and I don't need to edit any of my code, like any of my logic, right? This is just an input. So I can make another interval clock that runs every maybe day for Bitcoin or something like that, right? Like you can have parameters attached to schedules. And then you attach the schedule. So flow.schedule is this schedule, and then you can register it with that schedule. Other than schedules, we discuss clocks. Then we also have filters and adjustments. So these are like, don't run this if it's a weekday or a weekend. Don't run this between 9 a.m. to 3 p.m. Adjustments are things like, hey, if it falls on a Sunday, maybe run it the next, Monday or Tuesday, or mainly like that. Run it the next available like weekday. And with that, I'm gonna do a brief demo. Questions are welcome now, since this demo is quite not really too long, but will take a bit. I hope you don't have to listen to me for 1 hour straight, but so here we have this this is the flow that we just described earlier. So we get our data, detect a dip. Actually, yeah. So here we have this is what we ignore this first. So here is all of the code we had earlier. All that I'm doing is I am prescribing a threshold, and the default is 0. This is just so I can trigger Slack later, and I could get like an alert and show you guys that it's working. So this is everything. And then we registered to this project, and I am going to open Prefect Cloud, and this is the To the Moon project. So you're gonna see I already ran it earlier, right? So these are the 2 successful runs. You can go into that run. You can see the task that ran, but I'm gonna run it again over here. But before I run it, there's just one thing to explain, and that is the hybrid model. So with Prefect, one of the things that's unique about Prefect is that we run your workflows without even knowing anything about your data or whatever code you're running. So this makes us very like compliant to like clients in the healthcare space or clients in the or clients in the finance space, right? That really need some privacy. So how it works is that when Prefect, when you the cloud is basically orchestrating your on-premise infrastructure and telling your on-premise infrastructure, hey, there's a flow to run at this time. This is where you get the code, and then you execute it with this environment, right? But Prefect Cloud does not know anything about that. So this is quite a complicated diagram, but simply it's just that this is what we did right now. We made a flow on our laptop. We registered it with Prefect Cloud's API, so we can view it in the UI. And now whenever a run is scheduled, Prefect, there are these agents, right, that live on your infrastructure that pull Prefect Cloud every 10 seconds. And then once it finds out that, oh, there's something to run, then it starts executing that. It fetches the code wherever that is. it prepares the execution environment. Is there a Docker container? The agent is responsible for that. So this is entirely on your infrastructure. The execution is entirely on your infrastructure. And all we have is metadata on the cloud. But then once the agent, runs something and, oh, there was a failure, then you can use Prefect Cloud to send those relevant alerts where you can say, oh, there was a flow that failed, the agent told me, so I'll forward it with the Slack message, right? So that's how it works. So with that, let's go back to our flow here. And what I'm gonna show you is I have this agent running on my local machine, right? So this is the agent that I'm spinning up. So I'm just gonna say prefect agent local start. And this agent is now up, and it's gonna ping Prefect Cloud every 10 seconds. Hey, is there a flow to run? And if there's nothing, it just keeps waiting. So this is a long running process that communicates with Prefect Cloud. And then on Prefect Cloud, I have this to the moon flow, and I'm just gonna hit the quick run over here. So this should spin up a new flow run, and this is now scheduled. In a couple, you'll see it'll turn blue because it'll go from scheduled to like executing, unless my flow, oh yeah. So there's the blue, so now it's running. On the agent side, you'll see, hey, I picked it up, I completed the deployment. Now you see it succeeded, and as evidence of the success, we have this Slack task. So if I open Slack, you'll see that I got this message, hey, there has been a dip in Doge price, right? So with that, I'm gonna continue to more advanced flows, but if there are any questions, now is a good time also. I'll give it a couple of seconds. Okay, if there are none, I'll just go on. But, oh, can we see the schematic? Yeah, you can see the schematic. So here we have the two parameters that came in, the threshold, the coin. The coin was passed to get data. Detect dip, if you remember, takes in the data, takes in the threshold, right? So it's dependent on both of those. And then the case statement, if this is true, send to Slack, right? Can you talk about the question is, can you talk about the difference of prefect and DAS or how they work together? Yep, I have a section on that. We'll go to that next. So here we discussed like the basics of workflow orchestration. We discussed flows and tasks, which are the semantics of prefect. We showed how we can parameterize workflows, how easy it is to make retries. We talked about the task library. You saw how I pulled the Slack task, combined it with like a secret, right? And you would do this where like you have a database, you use the secrets, and then you make a connection instantly. I mean, with fairly low amount of Python code. And then I showed like conditional logic where we said, hey, if there's a dip, then I want an alert. And then we talked about how we registered that. We can attach a schedule when we register it. I registered it with Prefect Cloud, and from Prefect Cloud, from the UI, I was able to do a quick run. The question is, was that a static graph? The answer is yes. So there's two schematics that are made. Number one is when upon flow registration, right, during the build time, the schematic is put together and then viewed there in the UI. The second one is during runtime. And during runtime, it's not dynamic, but in a sense that it tracks the state of those individual tasks as it progresses through the graph for that individual flow run, right? So if I go back there and like this is attached to the flow run, right? And that's why you can see, I'm trying to zoom in here. Look at the duration, 1 second, 1 second, 1 second. So this was filled during runtime, right? Because post Slack depends on run. Could you elaborate your question, and I'll Majid, and I'll proceed. Okay, so going back with that, let's talk about prefect and DAS together. So So with Dask, if you're not familiar with Dask, Dask is primarily used, is most common when, for example, you have a pandas data frame and your pandas data frame is like, too big to efficiently handle in pandas. Then you need to move to a distributed compute engine like Dask, right? So, or Spark, right? So Spark and Dask are two of the most popular engines for distributed computing. So if you have a cluster, like these are the frameworks that you would use to take advantage of that cluster. Because Pandas is primarily single core and not as efficient with dealing with memory, right? So the main difference between Spark and Dask is that Spark is primarily built on the JVM. I mean, there's a lot of differences, but Spark is built on the JVM, and the Python it's built on with Scala, and the Python interface like has Python data types that get converted in order to be used by Apache Spark. Whereas Dask is mainly built on Python primitives, right? So it's a Dask data frame, for example, is just a stack of Python data frames, a pandas data frames. So how this works is that you normally have, so the client is the entry point, and the client feeds tasks to the sends tasks to the scheduler, and then the scheduler decides manages the allocation of the resources and decides where to send it for execution. And then if there's results, they get sent back to the client or scheduler, right? So this is like the Dask cluster. And what Prefect does is it lets you take advantage of the Dask cluster for parallel execution. So in this case, Prefect would be on your client, and then it would be sending stuff to the scheduler. So how Prefect interacts with Dask is it sends stuff to the scheduler. And in order to fully, so this is just to show that the pandas data frame is built, the Dask data frame is just a stack of pandas data frames, and then you're applying the operation on each pandas data frame. But this is not limited to data frames also. Dask has other data structures that like, for example, arrays, right? Like where you can have multiple numpy arrays, right? And that's why Prefect plus Dask works really well together. So Prefect was founded to make Airflow like a 2.0 of workflow orchestration. And one of the things that was that our founders set out in the beginning was to take advantage of the Dask scheduler in order to handle the execution of tasks, right? So Prefect was really built with that, taking advantage of Dask in mind. So when we talk about Dask and Prefect, there is like a native like synergy between these two, where you can use Prefect. You can use Dask as the execution under Prefect. If you don't use Dask, it's just a local executor. It's just sequential. But then it really plays. It really like a lot of people use this to parallelize very big tasks, and Prefect lets you scale however much your hardware can scale, right? So if you have a Dask cluster, 1,000 machines, right? Then you can use Prefect and send, like map a task across those thousands of machines, right? And with that, this also highlights one of Prefect's strengths, which is dynamic DAGs, right? So if you're not familiar, the DAG just stands for directed acyclic graph, or just the execution graph, right? And here, what we're gonna do is, instead of just one coin, I'm gonna provide 3 coins: Bitcoin, Ethereum, and Doge. And then I'm gonna get data for Bitcoin, get data for Ethereum, get data for Doge, detect the dip again for each of those, and then I'll check if any had a dip, and then I'll post it to Slack. What's interesting about Prefect is that when it comes to mapping, you don't know ahead of time how many elements you're getting. So this is actually a dynamic execution of the DAG, right? Where you can, it just depends on how many elements come in here, and that's how many like threads or processes you do. And by default, Prefect will use Dask to run these like threads like in a depth first execution way, so that they don't need to be collected like intermediate, right? So this can just be sent to the worker and processed before being collected. And with that, let's go to mapping first. So here, our parameter previously was Doge, and now I'm gonna do a list where I provide Doge, Bitcoin, and Ethereum. And all I'm gonna do is change the flow code. So get data, I'm gonna map on the 3 coins. And then this will give me a list of data frames now. I'm gonna map over that list of data frames and see if there's a dip. So now isDip is a list of true or false. And here I'm just making a quick Lambda task to get the maximum of those true or false values. If any of them are true, this will return true. If all of them are false, this will return false. And then that'll tell me if there's a dip or not. And then same thing, if there's a dip, I post to Slack, right? And then before we go to the Dask-like cluster, we can execute this in parallel on the local Dask executor, right? So what we can do is just do this, and this will use all the available cores of your machine. And then if we want to proceed to a Dask cluster, all you have to do is hook up your executor to a Dask cluster. So here specifically, I'm going to talk about Coiled. Coiled is just another company, and they provide managed Dask clusters, right? So the way it works in Coiled is I have to create a software environment. And this is just like a simpler interface to create a Docker container. So here I just create a software environment, put all my dependencies, and then in the Dask executor, for my executor, I'm just gonna spin up a Dask executor, put the coiled.cluster class and pass in these quarks. This is the software environment I defined earlier, and then I can shut it down on true. So now what's gonna happen is the flow will execute on a Dask executor. So it'll spin up the cluster, load the software environment or that image, run my flow on top of it, and then spin it down. And then I attach that executor to my flow. And this leads us to demo 2. So in demo 2, what I'm gonna do is I have this coiled dashboard set up, and I am going to trigger this with coiled. And I'm not gonna go into it so much, but so now is also a good time to ask questions. Coiled takes a while to spin up. We can watch the logs. I mean, just because it's a cluster, they're not slow or anything, but we're spinning up an actual cluster. Coiled also has like $100 or something for free that you can get started, or maybe $10, but you can see I'm just using cents here. So it's like per flow run. So it's more than enough to get started with Coiled also. So here, if we look at the logs of the flow run that I just kicked off, we are creating a new cluster. And if I go to my Coiled dashboard, you're gonna see that it's pending here. And then now we're getting like the 4 workers, and we're gonna, like use like those resources to run the Bitcoin, the Ethereum, the Doge. So questions are welcome. This won't take too long. Maybe like a minute or 2.
Question, Kevin. Are you seeing, this is built for Python. I assume most users are using mostly the Python stack with it, but you mentioned that with your task libraries there, people could use it with R and use it with lots of other tools also. Are you seeing a lot of people doing that, or is it mostly Python?
Yeah, because actually, like I've been seeing, we have a lot of like people in the biomedical field, and a lot of, I don't know what they are using, or if anyone here can relate, but like what they have a lot of like proprietary tech that, or like maybe they have, I've seen like stuff in C and Perl in like all these kinds of different languages, right? So how it works is we have a shell task in our task library, right? Over here, the shell task. And you would just like, it's like running a script, right? Like for example, it's Java, it's like Java something. For example, it's R, it would be R script something. So you can do that. The only downside is that we provide observability on a task level, right? And your whole R script or like Perl script or whatever becomes one task. But yes, we have a lot of this, definitely. And a lot of people chain it, right? Where you have like, I'm running a C program and the output gets persisted, then Python, then R. I've seen setups like that also, especially in the biomedical field, where they need a lot of those proprietary tech. So that's done. Here my Slack messages, there has been a dip in crypto price. This is the one that came in from this. So here this succeeded. Got the question on the schematic. So I'll just show you what the schematic looks like for a map task. The one you're interested in is this coin. So this, you'll see the map task. They have this blue, right? And it says, this is a bit small, but you'll see mapped here. There were 3 successes. So this is the dynamic DAG, right? To answer your question. So, and this is done during runtime, right? Because we don't know ahead of time how many coins are coming in, right? And actually with this flow, I also was I don't have time to go over the code of this, but for each of these, I built an ARIMA model, and I made a plot of like what are the predictions for the next 10 minutes, right? So here I have this for the Dogecoin, right? These are the ARIMA statistics. I didn't bother formatting it. The nicer thing is I have this plot here where this was the data that came in. That's my training data. And then I have the forecast. And then I have this also available for Bitcoin, right? And I have it available for Ethereum. So what you can do is you can send a Slack message to yourself, hey, there was a dip, check the flow run, and then you can go in here to the dashboard and see the artifacts that are attached to that specific flow run, right? The answer here, there's a question here, can prefect flow span tasks where the tasks are in different environments? Yes, this is very common as well, right? Because like you can have a flow of subflows, and a lot of people, like for example, they have one step that just needs a GPU, right? You don't want to hog that GPU for all the other like transformations or stuff that are like that don't necessarily need it, right? So what you can do is you can have I showed you that you can have executor, right? So here down here we attach the flow to the executor. Oh no, here to the executor. The executor here is what would contain the GPU. So all we need to do is make subflows with different executors and different resource requirements, and then we can just chain them together. This is also very common with like Kubernetes-based setups where you can control, or like ECS, like AWS, like a serverless like service like AWS ECS, where you can have a container that spins up. These are the resource requirements, so you can limit it that way. So yes, you can vary. You would vary the executors on a flow level, and then you would just group together multiple flows as into a main flow that runs them. And here for our data scientists, I mean, I did show the ARIMA model, but this is just some experimental thing that I think, so if you're very familiar with Dask already, there's Dask ML, and Dask ML lets you do like a parallel grid search, like multiple runs, and then collect all the results, right? For a lot of people who are not as familiar as with Dask, right? You can use Prefect to kind of use Dask without knowing the Dask syntax. Because earlier I showed you the map operator here, and this map is basically taking advantage of the Dask computation engine without having to know the exact syntax of Dask, right? So you can use, so when you use Prefect and Dask together, you're actually using the Dask engine, but with your Prefect or Python syntax, right? Where it's not, you don't have to like conform your code around Dask specifics, right? So here what we're gonna do is I'm just gonna make this task that returns 3 models, and I'm gonna return myself a linear regression, a ridge regression, and a lasso regression. And I'm gonna bundle this up in a list. So I have a list of 3 different sklearn models. And then I have this training, model training task, which is just basically, I needed to give myself features. So I'm just giving the lag 1 and lag 2 of the price, and then filling the NA just so my models work. And then here I have a model.fit with these features and this target. And then I just get the error like by predicting. I'm predicting on what I trained on. It's fine. The point here is just, I want to show you can map these model trainings with Prefect. And then here I have the logger where I'm just gonna log, I can pull out the model class name like this, and that will be your linear regression, your ridge, your lasso. And then I can also log the error. So I have this Slack task that's now, so this is a task inside a task now. And because of that, I just need to call the run method, but I can still use this task, right? And I'm providing myself a message, hey, the model, this had an MAE, mean absolute error of this, right? And I, again, like don't have to do anything on the flow side. I just have to get my models, and then I just map the model training, right? And what's going to happen is if I have multiple workers, those model trainings will happen on different workers, right? And I can log all of the results. So I have another demo before we wrap this up, and that is this model training grid search. So here we have the modeling, and I'm just going to do a quick run again. You're going to see the agent pick this up. Oops. So this was completed. Now this is spinning up. In the interest of time, I didn't use a coiled cluster. I just used a local executor. So this all ran. You're going to see the logs. You're going to see this, oh, this was ridge. This was the performance. This was linear regression. This was the performance. But also on the Slack channel, I sent myself these messages, right? The ridge had the mean absolute error of this, the linear regression had absolute error of this, and so on. So here we were actually able to take advantage of the Dask engine without having to code it up ourselves in Dask or using Dask ML, right? We use Prefect to parallelize that. And that's the main relationship of Prefect and Dask. So Prefect is just an interface to the Dask engine. When a lot of people do use it this way, so like if you have multiple data frames, maybe you don't need to use the Dask data frame. You can just, like, for example, people, what they do is they map these operations where they load an individual file, do some processing, save it out. And then if you have like 10 files, you can map it over those 10 files. And you can do the same. You can map it over Prefect as opposed to doing it in Dask. So the only limitation here is that everything that needs to be passed to a Dask worker by default, because of like the Dask engine, has to be serializable, and most like Python objects are. So here, like we actually, you know, serialized these models, got them in, got them into, you know, like pickle form, send them to the workers. The workers and pickles runs the task on the workers in a distributed setting, right? And with that, that's the end of my presentation. I just want to leave a couple of, I will send out my PowerPoint. And I just want to give a couple of resources here. So number one is, of course, Prefect Cloud. You're welcome to check it out. You get 10,000 free task runs for free. You get 10,000 task runs for free if you join. So that's a lot to get started with. Then, of course, you can check out our GitHub, our Slack channel, which is also posted in the chat. Yes, Catherine, my slides will be available. I'll make sure to send them out. And then, of course, check the Prefect documentation. And then there's a guide from the coiled side using coiled and Prefect together. If you want to use the Dask like executor and Prefect, coiled is also free. So it's very easy to play around with if you're interested. And then the last thing I'm going to mention before I open it up for questions is that we are hiring. We are hiring a lot of engineering positions. So if you're interested, please feel free to reach out to me. We have a bunch of, like, we're mainly a Python shop, but we also have some front end positions open. We're open source. That's a very fun part of working with Prefect. All the work is like on GitHub. So we're looking for these types of like positions, but really, if you're just interested, just send your, just connect with me and we can chat about it. These positions are not strict. Then we also have marketing and business development representatives. So yeah, you're always welcome to chat with me about Prefect, about workflow orchestration, or about data science even. I mean, I'm a data scientist myself. Feel free to email me at kevin@prefect.io. you can reach out to me on Slack. It is 80% of my job to be there on Slack and to maintain that community. So, and I certainly like have learned a lot just from a lot of other community members, just because there's a lot of really good people, really helpful people hanging out in our Slack community. So feel free to join. And if you want to check our jobs page, it's down here. And I will link my slides. And with that, I'll take any questions. Stop sharing here.
Great, thank you, Kevin. I got a question here while we're waiting to see if anyone else has other ones. What's next for Prefect? What are the next features you all are looking to add? Looks like you just added that artifacts feature pretty recently, so that's cool. What else is ahead?
Yeah, without going into much detail, since it's not public yet, there is work in progress that really tries to push the boundary of workflow orchestration. There's a lot of new development happening. All I can say is like stay tuned, like for like 3 to 6 months out. Also, our product manager is in this chat or call. I don't know, Bill, if you want to say something about that.
One sec, Bill. You.
Oh, can
you
unmute?
Yeah, you're a co-host now, so you should be able to.
Thank you. Appreciate it. Yep. Yeah, as Kevin said, we'll be doing some more work over the next, in particular, 3 months. But with regards to pushing the boundaries of workflow orchestration, a lot of the constraints that we operate in today are kind of vestigial holdovers from the way orchestration tools were built, going back as far as 10 years ago. Things like, for instance, requiring that a graph be directed acyclic graph, a DAG. That is kind of a holdover from YAML files as orchestrators were originally implemented. There's ways of potentially loosening those constraints. Earlier in this discussion, we talked about other languages that data scientists are working in. The R community has come a long way in terms of enabling functional programming. So we ultimately want to meet data scientists and engineers wherever they are, which is going to be loosening constraints on the types of workflows folks can build, and also building more clients to interface with our APIs.
Cool, thank you.
Yeah, I can take this question. So Majid is asking, can you elaborate on the fundamental difference between Dagster and Prefect? And I'll say is this, right? So Dagster, if you guys are not familiar, Dagster is another orchestration tool. Dagster and Prefect are very fundamentally different, right? Because Dagster has certain requirements that require you to be in their world, and if you subscribe to those requirements, then you can run your workflow orchestration in their world, and they're primarily data focused. So for example, they have like a type checking feature, but in order to take advantage of type checking, they kind of need to see your data right ahead of time, right? Whereas Prefect, first of all, in regards to type checking, there are things that we are exploring also on our end, such that we can provide type checking in some way without having to look at your data. But the fundamental difference is that Dagster sees your data and actually is very think of it as invasive, whereas Prefect is very hands-off in that sense, where we want you to be able to do the work that you want to do without really having to prescribe requirements. We want, if you saw what I showed here, everything is very seamless. Everything is if I had to change the executor, if I had to change or the mapping or stuff, those happen in the flow definition as opposed to your Python code, right? So we try to be very minimal about your the changes to your existing code, and hopefully it's just that decorator with a couple parameters, and with that you get the workflow orchestration like in Prefect. So but added to that, we also have a lot of data. I mean, we can run your flow without knowing anything about your data, since we just keep metadata. Sorry, could you the question is, in other words, Dagster is more functional programming while Prefect is more task oriented. I think is the question. I don't think so, because they both have functional APIs, but it's more of the like actually like being invasive into the data, because they are more like a data lineage tool, right? Whereas Prefect is more closer to a general purpose, like pure workflow orchestration tool, if that makes sense. Like if you go to their website, it says data orchestration, right? Whereas we are general purpose workflow orchestration, right? So we don't, today I showed you work that happens in data frames, but it doesn't even have to be data frames, right? You can literally just do anything as long as it's Python, wrap it in a task, it can work in Prefect.
Cool, great. With that, I want to say thank you to Kevin. I do want to, I said we'd leave a quick time for announcements here. If anyone else has announcements they want to share, if you want to put that in the chat, that's great to let people know about that. And otherwise, we will look forward to seeing you in a couple of weeks for our next meetup. And appreciate you all joining us this evening, and hopefully look forward to seeing you before it's too long in person. So thanks again, Kevin. Appreciate your time coming out.
All right. Yeah. Thank you, everyone. Thank you for coming on a weekday night. It's nice hanging with you all.
Thanks, Kevin.
Have a good night, all. We will get the slides up on Meetup or link to them. Kevin, if you pass those over our way.
All right. Thank you. I'll see you.
Bye, everyone.
Bye.